Now the next topic to discuss with connection to functions are piecewise functions. Now piecewise functions are functions that are broken down into parts with different types of equations that go along with each part. And here is an example of a piecewise function. It says f of x is equal to 3x plus 5 if x is less than or equal to 0, or f of x is equal to 4x plus 7 if x is greater than 0. So we have this indication of the value of x, and if it's in different numbers, it'll go into different parts of the piecewise function. So if I want to calculate f of negative 2, we look at the number for negative 2. Since negative 2 is less than 0, it's going to be plugged into the top piece of the piecewise function. So in other words, we're going to plug negative 2 into the 3x plus 5. So it would be 3 times negative 2 plus 5. 3 times negative 2 would be negative 6, so negative 6 plus 5 would turn into negative 1. For f of 3, we notice that we have the number 3 here for x, and that's greater than 0. So what it tells us to do if x is greater than 0 is to plug into the other part of the function. Plug into the bottom part of the function, the lower part of the function. So it would plug into the 4 times 3 plus 7. That'd be 12 plus 7, or 19. And so we're going to work through a few examples now of piecewise functions and go through how we construct and graph the different types of functions. The first example says a cell phone company offers the following plan: $20 per month by 60 minutes, and additional time cost 40 cents per minute. Write a piecewise function which represents this plan, and what is the cost for 50 minutes or for 100 minutes? So to construct a piecewise function from this description, we'll have basically breaking it down into two parts. First off, let's call our function by a name. We'll use the capital letter C to stand for cost and X to stand for the number of minutes. So C of X will be equal to the cost for X number of minutes. And now we can construct our function as a piecewise function like so. We write C of X is equal to, and then we write this large thing which I call a curly brace. It's kind of like a bracket of sorts, but it's kind of curly like this. And up on top, I'm going to put the first situation that could be paid for. It says it could cost $20, but that happens if the number of minutes is 60 minutes or less, because it buys 60 minutes. So we write that as $20 if X is less than or equal to 60 minutes. And that's the first part. Now the second part is if it goes over 60 minutes. Now if it goes over 60 minutes, it's still going to be $20, but we have to add to that the additional cost for 40 cents per minute. So we're going to start with $20 plus 40 cents times something. That something is going to be times the number of minutes over the first 60 minutes. So in these parentheses, I'm going to write something down for the number of minutes that's greater than 60. The way we do that is we take the number of minutes, which is X, and we subtract away 60 from that. Because let's say we used 85 minutes. 85 minutes minus 60 would be 25 minutes over. So as long as I subtract 60 away, what I'm left with is the number of minutes that are over 60. So we're going to multiply that by 40 cents to get how much is being charged for going over 60 minutes. So it'll be $20 plus this amount if the number of minutes, X, is greater than 60 minutes. Now we can calculate some things with this. For instance, if we want to know for 50 minutes how much that would cost, we would do C of 50. Since that's less than 60 minutes, it's just going to cost $20. Now for 100 minutes, the cost would be calculated by C of 100. Since this is greater than 60 minutes, we're going to still pay the $20 plus 40 cents times 100 minutes minus 60 for the amount over the 60-minute barrier. So it's going to turn into $20 plus 40 cents times 40 minutes over. That comes out to be a total of $36. For this next example, it says graph the following piecewise function. So f of x is equal to x plus 2 if x is less than or equal to 0, or f of x is equal to 4 if x is greater than 0. Now to make this a little bit easier to understand, what I'm going to do is plug in some numbers for x and then get out the corresponding numbers for the function f of x. For instance, if I plug in -2, -2 is less than 0, so I plug it into the top part, -2 plus 2, which would be equal to 0. So we're going to plot a point -2, 0. For -1, that would be -1 plus 2, which would be +1. We'll plot a point there. For 0, we'll still plug that into the top. 0 plus 2 would be equal to 2. So it would go up here. Now for every number after 0, it changes, because the function says when it's greater than 0, it's equal to 4. So after that, for x equals 1, it's 4. For x equals 2, it's equal to 4. And everywhere down past that, it's just going to keep continuing on that number. So it kind of jumps up all the way to 4 up here. So how we're going to have to draw this is the first part of the graph is a line that travels like so. And then after it gets to 0, it jumps up to 4, continues on from there. Now technically I do put a little circle here at the number 4. And I do that because there's a filled-in circle down below it already used. So a lot of times when we do piecewise function graphs, you'll see an open circle at the location where it jumps from one number to the other. It uses the number down here at 2, and then it jumps up to the number 4, but it doesn't actually go right on top of it. It just continues there as a flat line at the number 4. Now for the domain, we look at the x-axis and notice that it covers the entire x-axis since it continues to point off to the left and to the right. So the domain would be all real numbers from -infinity to +infinity. For the range, we look at the y-axis and see that it comes up from the bottom all the way up to 2. And so the range would cover everything from -infinity up to 2, including the number 2. But then it's going to jump up to just the number 4 up at the top. So the way we write this for the range is we write the interval from -infinity up to 2 and close it with a bracket. And then we write this U sign in the middle for union with the number 4. The last topic for this section is the difference quotient. Now the difference quotient is kind of going beyond the scope of college algebra. It's actually more of a topic that's dealt with in calculus and related topics. And mainly it's a measurement of slope. And we'll talk a little more about slope measurements in a future section. and also something called average rate of change. For now, however, let's just think about the algebra behind calculating this thing called the difference quotient. I have it listed here. It's f of x plus h minus f of x all over h, where h is not equal to 0. And I have a few functions here that we're going to use to calculate the difference quotient. Okay, so on the first one here, where we have f of x is equal to 3x plus 7, I kind of do the difference quotient in several steps. The first step is to calculate this thing called f of x plus h. We do that by taking our function and substituting in for the place of x, the x plus h. So it'll be 3 times x plus h plus 7. Often we'll go ahead and distribute the 3 into the parentheses here. So that would make it look like 3x plus 3h plus 7. That's our first step. Our second step is to do f of x plus h minus f of x. So that means is we can take what we have from the last step and we subtract away f of x, which would be minus 3x plus 7. We're subtracting both the 3x and the 7, so both of those will be negative. Basically, the negative distributes to both terms being subtracted. So we're going to get 3x plus 3h plus 7 minus 3x minus 7. Now I can cross out the positive and negative 3x. Also can cross out the negative and positive 7, leaving us with just simply 3h. Finally, the last step is to put this all together into the difference quotient, f of x plus h minus f of x all over h. So up on top, we put the 3h divided by h. We can now cross out the h, and we'll be left with just 3. And that's what we call the difference quotient for this function. Okay, now for this next one, we'll go through the same steps, starting with f of x plus h. Now looking at the function up above, we have x squared. So in the place of x, I'm going to put x plus h. So we're going to get x plus h squared minus 5 times x plus h plus 8. Okay, the tricky part here is where we have x plus h raised to the second power. Keep in mind that when you take x plus h to the second power, it means you're multiplying it by itself. So it would look like x plus h times x plus h. To save a step here, I'm going to go ahead and distribute this negative 5 into the parentheses, making it into negative 5x minus 5h. And then at the very end, we have a plus 8. Okay, we do need to take care of the algebra here for distributing or foiling out the x plus h times itself. So again, FOIL means we got to multiply the first. So x times x, so that'd be x squared. The outer would give us a plus xh. The inner would give us another plus xh. And then we got to multiply the last together. So it'd be h times h, so that'd be h squared. Minus 5x minus 5h plus 8. So in the end here, we'll have x squared plus 2xh plus h squared minus 5x minus 5h plus 8. That's step 1 of the process. Step 2, we're going to take f of x plus h minus f of x. So we're going to take everything from our last step here. We're going to subtract away the original function x squared minus 5x plus 8. Notice how I kept it in parentheses. That's on purpose because I'm subtracting each and every term. I have to make sure to keep that negative and distribute it to everything. So I'm going to write this down one more time. So it'll be minus x squared plus 5x minus 8. We should be able to cross some things out at this point. Namely, we have a positive x squared and a negative x squared. We have a negative 5x and a positive 5x, a positive 8 and a negative 8. We can cross all those out. As a result, all that's left will be 2xh plus h squared minus 5h. The last step is to put this all together into the difference quotient. F of x plus h minus f of x all over h. So up on top, we take what we just wrote down from the last step, and we write that all over h. Now the next thing to notice is that everything on top, all three terms, have an h in common. We can factor out that h and write it as h times 2x plus h minus 5 all over h. That's an indication that we can cross out that h from both top and bottom. And all that's going to be left over as a result is just the 2x plus h minus 5. And that's our final result, to call this the difference quotient for this function.